Okay, so we are live, not live. Well, we are live. We are live, but we're recording this for a building query call slash demo of the work we did in Sprint C. And today's February 13th, 2020. So to lay out what we're going to do today, I think we've got kind of three presenters. Chris will go first, then we'll have Casey, and then Brendan. Chris, we're going to have you walk us through the blog post you wrote, as well as unfurling links on Query Cloud and Query.io so that people can get a little previews of what those will look like. And then Casey will take us through the Browse and Network tab and desktop coming in 040, I think, right? Ish, soon. And then B5 will demo quote unquote backend stuff. So that's all we've got for an agenda. I think I'll pass it to Chris. And let's just have a general rule that once you're done speaking, go ahead and mute since we don't have the mic for this one. So I'm going to mute right about now.
Can you hear me now? Okay, so I'll show this blog post that went out this week. It's kind of different than other blog posts on our blog. Calling it a data story, which is akin to a data journalism piece, but we kind of wanted to make an interactive, inspired by the types of things you might find in the New York Times, to just tell an interesting story from a data set. So this one was something I personally wanted to do for a while, which was log some real-time bus data and just see what kind of patterns you can see in sort of a short window of time for one specific bus route. Selfishly, I chose the B67, which is the one I took to work, which I often observe sort of bunching and spottiness, delays, all kinds of things. So kind of the flashiest bit after you get into sort of what we actually collected is this little animated chart. Remind me to go back and look at those widgets. But this is actually, using Mapbox.gl, interpolating the 1 minute frequency. We basically have 1 minute observations of each one of these buses. So we took the real-time API, logged it, and then we're able to interpolate for a nice smooth animation of vehicles along the route. So you can kind of get this overall picture of vehicle speed, sort of when they start slowing down. It becomes very interesting once it goes. Basically, we're looking at a 3-hour window, and you can kind of see when rush hour takes hold, when the streets start getting a little more crowded after 7 a.m. It has a big effect on buses. Another interesting outcome, if we scroll through that, you should go check it out on your own, was this. This is kind of a stacking the the expected wait till the next bus over the course of the entire route, northbound and southbound. And what's interesting here is that you can see that there are large delays that can cascade and become larger and larger as you go along the course of the route. And also what was interesting to me, even though we didn't really analyze it, is that the real-time information is actually is less available if you're closer to the route, because it basically downstream stops can't predict that a bus is coming until it's actually started the trip. So you can see there's more information as you get further down the course of the route. The ones towards the beginning don't have much. So there's plenty more to look at, but I'll just leave it at that. Here's our interesting chart with rush hour. But I want to draw your attention to these guys right here, which are query dataset widgets. So these are effectively a call to action to go check out a dataset. We've got some dataset stats. We've got a title. We've got a big clone button. We've got some view counts. So this is kind of a prototype. The intent would be that these are things you can very quickly get an embed iframe code for Query Cloud and just drop them anywhere. So this is kind of a first run at getting them onto a page somewhere. This does indeed take you over to Query Cloud, so you can check out the data set behind this analysis and read a little bit more about where the data came from that's not necessarily covered in the blog post. So that's that. I think that's all I have to demo today. But yeah, we hope to be doing a few more of these, for forever. So that's all I got for this round. Should I wait for the unfurling?
Go ahead.
Okay. All right, so I have, well, let's do it this way. So if we go to Query Cloud and we get this is a popular testing data set, World Bank population. Am I not screen sharing? Really?
Turn it off.
I did? I didn't need to do that. Somebody else turned it off for me.
I put zero.
Sure. Okay, here we go.
Sorry.
All right, so here's a B5 World Bank population, our favorite starter data set for query users. We can go to this card validator for Twitter and hit preview. All right, so what we've got here is it is pulling out the title of the data set and appending this little query data set prefix to it. It's taking the description from the metadata and actually like summarizing it here, and then we've got a nice little square query logo. So these will actually work both in Facebook, anything that uses the Open Graph and the Twitter card standards. So these look great in Slack, they'll look good on Facebook, they'll look good on LinkedIn. So now basically Query Cloud and Query.io both have these improvements. And then for the more technical, we can inspect the body here, and I'll show you basically where these ended up. But inside the head, you will see lots more meta tags. And these ones that say things like Twitter title, OG title, basically have the same value, but the Twitter ones are the ones that show up in Twitter cards, and OG is the ones that will show up on Facebook and other places. So now we've got these, our bases sort of covered there. And last thing I want to show is that there's also, let's see if I can find it in here. Let's see, I think it's going to be down here inside the script tag. No, not inside the script tag. There it is, application LD plus JSON. Okay, so what you're looking at here is LD JSON, which is basically schema.org structured metadata for a data set. And this is what Google Dataset Search would like to see. Oh no, I lost it. Anyway, so it's inside a script tag, and it's inside all of our dataset pages, and now those are, in theory, discoverable by Google Dataset Search, and we hope to see Query Cloud results showing up there as soon as the bots come and check out Query Cloud. So that's all I've got to share.
Is it my turn?
It is.
Okay.
You want me to be muted? Yeah. Okay.
Okay, cool. So let me share my screen. I'm going to show you guys, share my desktop. I'm going to show you guys our network browse experience. So actually, the first thing I'm going to show you is Query now has a little DMG icon that's different than its app icon, and it's so cute. This is what you use if you're on Mac to install Query, drag it into the applications folder. Okay, so right now, I am running a version of our cloud software locally, and on it there is a data set that is in the cloud that I do not have yet, but I can take a look at this data set when I look at the network. So this is our home feed cloud, like the actual Query Cloud has a lot more data sets than this, but this synthesizer data set is coming from the cloud. So if I click on it, I get a preview and I can take a look at some commit information, overview about meta, the title, the structure, schema, and a sample of the body. You notice here, this over here is the data set history. You'll notice that it is grayed out. That's to indicate that you do not currently have that version of this data set on your machine. You see right here is a clone data set button. Cloning is how you get a data set from the network to be part of your local query. So I'm going to clone that. It moves me to my workbench. And here I can actually then check the data set out, make changes, or just explore it more. And if I have a data set that I currently own, so this is my test CSV data set, very complicated, I can publish this to the cloud. And once I publish it, it ends up in the feed. There, if you guys also notice, there is a search bar at the top. I can search for example, since I can search on the cloud and I can get I can get search results here, or I can just search locally, and which is kind of funny because I have both things on my local environment and the cloud environment right now are the same. But if you search on cloud, you'll be taken. Oh wait, no, that's local. But if you search, you're taken to your data set. Now I am going to remember. Okay, if you notice here, I had already added this data set, so now this version shows that I currently own it, and I can't clone it again because it's already been cloned. But I can if I push another version to the network, and we look here. So what I did in the terminal is I told Cloud to make another version, another commit to this data set, and then when I went to look at it, now it's showing me that, hey, there is a version that you don't have of this data set. I can explore that version here, but I would have to add it specifically in order to get it into my machine. So yeah, that's, oh, look at that. Brendan pushed the data set. Lovely, lovely. And look, I don't have any version of it.
Can we just quickly clarify what it means, the a year ago? Does that mean Brendan generated it a year ago and pushed it now?
Exactly. This commit here shows this here shows details about the commit, not when it was published. So he published it just now, but he actually worked on it a year ago.
Cool.
And I can switch through and see the different versions of, well, I guess there's some error here. But yeah, so yeah, there you go.
Any questions from the team on behalf of people who might be watching this? Or I know we're all insiders here, but
So when is that coming?
Sorry, say it again?
When's that coming out?
In our next release, which I assume will be probably Monday or Tuesday. So soon. Tuesday. Oh yeah. Word. Tuesday.
It's on 18th. 18th is Tuesday. February 18th.
February 18th, coming at you.
Cool. Any other lingering items on that? We can go right into the back end. All right, B5 with the back end.
Cool. So I went on a bit of a low mission yesterday to work on some stuff we've been thinking about for a while, and I just want to give a sort of quick preview of some stuff that'll probably not be coming out for a couple of weeks at the earliest, but this is a feature we've been sort of aiming to build for a long time at Query, and so while I said this was backend, it's not very backend, it's also front-end as well. But internally, we've been talking a bunch about, well, let me share my screen. We've been talking a bunch about this problem of like tracking changes and understanding what a change means and being able to quickly sort of get at a change. Any sort of version control system worth its salt can sort of show you quickly what is different between two versions. And so today I want to just show a demo of where we're hoping to take the idea, like our sort of first steps in terms of comparing stuff on the front end. We've been thinking how to properly visualize differences for a long time. We've been working on the infrastructure for it for a long time. And our first sort of stab at this, we thought we would land this first as this kind of concept of a compare view. And so we've had the idea for this for a while, but it's taken us a little while to get into place the stuff that we need to be able to compare this. And so where I thought we'd start as a demo is just being able to do the classic comparison of two CSV files. And so what I'm going to do is I'm going to go to the, this is the thing we use a lot, which is the US Geological Survey's earthquakes. And we often use the significant earthquakes. And what I think is kind of fun here is if we look at this data, I'm going to look at significant earthquakes and then magnitude of 4.5 plus. So significant, and the nice thing is these are two data sets that have the same schema. If we look at this sort of first line, we have time, latitude, longitude, depth. Same thing here, we have time, latitude, longitude, depth. And these are both from the same time period. And if we read the thing, it should theoretically mean that significant earthquakes are probably of a higher magnitude of 4.5, right? And so you can sort of imagine that everything listed here in this significant list should probably also be in the 4.5 list, but we don't really know that, right? And so we can actually use a differ to see if that's the case. And so I'm going to download these two files. And so now they're both going to go into my downloads folder. I sorted my downloads folder before this demo started. But what I'm going to do is I'm going to go over here. I'm going to click. So the minus is what I want to show as being subtractions from in the diff. And so I'm going to go with the significant. Let's do the big magnitude of 4.5 list on the left, or that's the minus, and then the significant month on the right. If we do this, it's going to go to the backend and calculate for us a diff, which is going to show all kinds of stuff, which is kind of fun. And I wired up this fancy button so we can actually switch them really easily. So now this will just visualize it the other way, where now the 4.5 magnitude earthquakes are shown as additions to the list, and the significant ones are shown as subtractions. And then anything where they both match is shown as just plain. And this is always fun. You can just show you can get a non-existent diff by just comparing something to itself, and you get this nice thing. We can also just go back here for a second to do, what was this, 4.5 month that we're doing? Yeah, that one. So yeah, just to talk through really quickly what this is like, it's properly calculating for us. If there was a difference in schemas, it would actually show that. So we can very quickly come in, and I'll use a text editor. Let's see a text editor. We've been talking about edit features for a long time too, because this is irritating, but where's VS Code? Where are you? Oh my gosh, VS Code.
Live demos.
I know, right? Okay, so if we change time to time and hit save, and that was on significant month. Oh yes, I don't need to drag over here, buddy. It's okay. No, okay, good. And then we read it significant month. Oh no, go away. Reload. No. It thinks I want to drag over it, and then I'm like, no, I don't want to drag over it. But that's okay. Here, I'm just going to close this and make a new one. Tron file. I can't do this, can I? I have to reload. Irritating. Anyways, it can diff schemas. Let me see if I can get this up and running again. But the big thing is we actually have something that can sort of run some of our diffing algorithms under the hood now, which has been a very exciting and long time coming, I think.
So question,
yeah.
It showed like the lines like deleted and added.
Yeah, yeah.
Is there like more significant diff stats coming? Like is that?
There are much more significant things on it. So the question was, are there more significant diff stats? That diff stat that I sort of am showing is just number of edits. And so an edit can actually be a full line deletion or a single cell deletion. So if you're seeing like, they aren't weighted differently. And so right now that's just like sort of a pure number of like, this thing edits 300 things or subtracts 300 things and adds 300 things. So this time, let's just to close out the demo here, because we do 4.5 months, cool. It takes a second when it's in dev mode to actually like pick the thing sometimes. And then significant month. And this time we should see the like actual time. Oh no, we don't see it. Oh well, I didn't save it, whatever. It'll pick up on schema diffs, it's great.
So sorry, what's the one we're seeing?
Here?
No, just the one that says something actually changed in the row. That's probably not.
It's not actually real. Yeah, and so these are rows that are extremely similar that look like they could deduplicate but aren't actually the same. This is where this is truly a demo, because we have to kind of tune this algorithm a little bit to understand where this is.
Is that a string versus splitting point?
Exactly. What you're seeing here, it's a query under the hood is actually inferring one of these data sets had a much cleaner schema inference, and so it actually came through. And so a couple of things we're going to want to be able to do is actually override the schema, which would be really nice. But this is picking up on a difference in types, because if you look at the two data sets, this one is short enough that the, what was the thing that we were seeing an error on? Depth, yeah. And so like depth in this one, yeah, depth is showing no sort of like errors or anything. But if we get into the longer data set, I guarantee you there's some column, some part of the depth column that is containing like non-numeric characters or things that don't resolve to numbers properly. And that's probably what's throwing off the depth or the schema type inference system. Is there not? Wow, that's looking pretty clean to me. I don't know, we'll have to.
There's some subtle things that happen,
yeah,
especially with larger data sets.
But basically, it sort of took a guess at the schemas for us, and we can be able to tune this over time.
What about the one at the bottom of your screen right now?
This?
Yeah, what's going on there?
And so here, we had pretty massive deduplication across this like definition of earthquake. It sort of, the algorithm picked up on this and said, oh, cool, these things are the same. And then it's like, well, no, obviously these aren't the same. This is, and so this is actually, we can tune this. The algorithm itself uses a weighting system for deciding this kind of thing. So now that we have this in place, we can actually start to play with the parameters around how much weight it takes to trigger something to be triggered as the same or different. What is nice is this is a composable diff. So like you can actually, this can produce a patch, and you can, and the patch will, the script it produces will produce, will correctly transform one thing into the other thing. And so while the output might look a little tough to read, it is in fact correct semantically. And so the idea here is we just don't want rows that are this different to be deduplicating. But we are seeing rows that are completely the same are showing up and are absolutely there, which is great. We're just seeing, and it is picking up on this type difference, which is really nice. And then these rows that are purely removed are also being completely picked up. And you can kind of tell that by, in the edit script, it changes, it produces this different depending on which way you do it, which is a nice indication that it's working. But yeah. So this works on real data, which has been really fun. Yeah, that's what I got.
Cool, so that wraps the demo we wanted to show off to ourselves and to viewers. We do have 2 open job postings, one for front-end dev and one for back-end dev. And since this is the building query call, I wanted to know if anybody here wanted to give 60 seconds to describe any one of those specific roles. And then we can send this to some of the people that have applied and just ask them to watch the last couple of minutes to get a feel for, because we'll be doing interviews and you'll be saying the same 60 seconds little pitch 40 times or however many people we interview. So getting it out now might be sort of a helpful thing to have them watch and get a feel for it. So whatever you'd like to say about the front end role, we can do that one first. Tools you'll be using,
Yeah.
person you'll be working with, something like that.
All right, do you mind muting?
I can take it because you're making us all, throwing us all a curveball here. Yeah, you should totally come work with us. If you do, you'll be working on, if you apply for the front end role, you'll be working on our TypeScript, JavaScript, Electron stack. I'll quickly share my screen because the first place we're going to send you is all of our code. All of our code is open. And so if you go to github.com/query-io/desktop, this is the code that we're working on. This is the pull request from the demo that we just gave. We have to get CI to pass. If you're into this kind of thing and you read through this repo and you're like, wow, the work that they're doing is actually neat and they're doing it well and they comment their code and they lint their code and that sounds good and they write tests and that sounds good, you should totally come join us. This is a great place to find out what day-to-day work looks like. Going through pull requests that are open and closed in the past is a great chance to see sort of how we work. And it's literally this, so there's nothing hidden or scary to look at. How's that as pitch?
Great, good start. Backends?
Do you want me to do it again?
Yeah.
Yeah.
You're better.
I'm seeing a lot of people look at me. So same deal with backend, but let's go and show you the backend code. I think backend's exciting in the same way that front end's exciting. We just kind of take pride on being decent at our jobs and using decent tools and good process. And I think that applies to both backend and front end. We've refactored front end many a time, bringing in tools like TypeScript and bringing in processes like end-to-end tests. Same system with our backend. A lot of our backend is written in Go, and actually all of it, yeah, the entire thing is written in Go. And like here, we use a lot of the like plumbing and porcelain pattern of like each of these folders to generally represent something close to a subsystem, obviously like not an API, but yeah, we're pretty proud of this. This one has been around for a long time. This is have a number of commits on it. It's a growing open source project. If you're into decentralization, peer-to-peer systems, if you're into hard problems, definitely come join the backend, apply for the backend position. It's great. And yeah, definitely have a look. Folders you should totally look at. We spend a lot of time on the lib stuff, making lib work, right? So if you want to see how the diff command works that I just demoed, this is the main entry point to the diff function. And we can sort of walk all the way through here. And again, if this seems interesting, you should call us. Awesome.
Wonderful. Cool. Thank you very much for that. I think that's going to be really helpful. Any other closing thoughts, questions, confusions, conundrums? All right, cool. So that was building query / sprint C demo. Next up, D. See you in 2 weeks.